Like biscuit. Oh, yeah.
First we see the counter function first.
What is that?
Function block.
And then also LC, interlock LC.
IL interlock. Create new project. No, you can change the PLC here. Yeah, right. Yes. You want L E. Yes. Setting.
Yeah, what type?
Ethernet. EM, okay. Okay. And complex BC. Close this. Okay, go to section. Yes. So first we see the counter function first. We put normally open. Okay. You can use the first button, first switch 0.0. 0.0, okay. Name it as a sensor. Okay. Then the counter is, take this one, or this can type also can C and T.
Which one just now? Which one? This one.
No, the instruction is C and T. Space 0 space. Okay, how much you want to count? 10. So hashtag 10. After C and T is enter.
CNT is
BCD counter.
how do I know it's BCD count?
You can check in the help. Okay, then so you add another one 0.01. Now we open. Yes, 0.01. Reset. Okay. Then you just join until here, the line. You can use controller. So counter very simple, similar to timer. Okay. So timer, how the timer works? When the input on, timer start to count. Once I reach my value, the timer will give me output T0, right? Same goes for counter. So the counter output is the C0. Okay, put it here. Normally open. C0. Enter. Okay, just put name counter 1. Okay. Then output. Just put one output. uh, 0.0. Yes, lamp 1. Okay, so very simple. So when this one on off, I count 1. So if I on 10 times, then the counter will be energized. So the counter energized and on the lamp. So if I want to off the counter, need to reset. For the timer, if I want to off the timer, what I do? I cut off the timer inputs. Okay? Just go online, download, check. Save.
Transfer.
Yes, of course. Yeah.
Transfer.
Online first. Look online first.
Reset the device of the CS programmer has the type of PLC referred to.
The
This one is CPY LVM. It's not
lamp 2 is not working. Okay, now. Okay.
okay.
Now go offline.
RL.
IL.
IL.
Enter. Okay. Now go to next slide. Do a simple program that is okay, the counter, the C0. Okay. Okay. We add another output. Lamp to 100.01. Lamp 2. Then go to the next one. No, go to the next line. Okay. Not this one. No need. Cancel. Escape. ISC. Yeah. It means interlock here and I clear here, right? Okay. It means the program inside here, okay, only can run when the interlock is enabled. Okay. If this one is not enabled, the program inside here cannot run. That's all. So program before this and after this run as usual. Okay? Okay? Try this. That is a function of interlock.
Okay.
You downloaded it, correct?
Alright.
Monitor? Tested it,
Yes,
yes?
sir.
You understand?
Yeah.
Okay. So it means very simple, whatever it so means sometime okay, there will be some program inside there, right?
Yeah.
Okay, let's say if okay, you see this one on now. Okay, you off it now. You see, it shows this one on, but you can see output not working.
Yeah.
Okay, it means it can the input can. So the concept is okay. We know how the PLC works. PLC will scan left to right, top to bottom. So PLC scan this, okay, give the output, right? Then PLC scan this, okay, energize the output. On this place, PLC won't scan. Okay, so that's why even though the input is there, there's no output. Okay, I interlock, I on, then only the output is on. Okay, that is the interlock function. Okay, go offline. Okay, now what I do, this one you keep aside, you create a new project.
New project.
You see what is function block. CP1LE.
What?
Yeah, CP1L is different, CP1LE different. EN, okay? Go to function block. The function block here. Yes. Right click, insert function block. Okay, so you can use ladder or structure text like. Okay, go to ladder. Okay, this function block name motor control. No space, you can put underscore. Okay. Right. Open motor control. Open. So inside here, I can do a logic. Okay, it means okay. You see how the SCL function work.
SCL.
SCL, right? The scaling function. Okay, to input the first parameter and the output. Okay, it means actually inside there is a logic, a program, coding, right? So means which is Omron already created for you. So you can just use multiple tab, each one different for analog input, analog output, right? Same concept for function block. It means we can create our own block. Then we can use multiple tab. Okay, so for example, I just want to create a simple one. So, okay, here input, output, in, out, external, internal. Right, okay, it means once you create this block, okay, then this block later you can call, you will be add in the section one. So it become like this, a block. So motor control. So whatever you put as an input will be here. Okay. So just put in 1, in 2, Input. Whatever you put as an output will be here. Out 1, out 2, out 3. Okay? Whatever you put as an input, I just come like this one. In out. Okay? Internal means whatever we put here in the internal will be inside the block. Okay? External means the external addresses. Okay? We do a simple one. Okay? We go to input.
Okay. One question for the when you see the screen and what you see you have input, output and output. This is the standard that we refer to the graph.
Yes. Okay, that one is difficult, right? Right on the SCL because you need to know the what?
The instrument, the kind of
Yeah, of course. What is the range of the instrument, and also you need to know the BCD, binary, everything. So if you don't want to use SCL, you can create your own block here.
Okay.
But one time I need to do the calculation. The whole calculation you need to do. Then just can use. Okay, we do one, so you can understand. Okay. First we do a simple one. Okay, go to input. Okay. Right click here. Insert variable. Okay, start. Okay, it's a boolean and it's an input. Input. Okay, clear. You add another one. Insert variable. Stop. Input. Okay. Then go to output. Right click. Insert variable. Insert variable. Motor. Okay. Yeah. So the internal and external or later we see. Okay. Now you do a simple program here. The start stop motor. Click here first. You do the start stop motor using this one. So you click here. Go down. You can see the start stop. Okay. Okay. So no address up here. Okay. Normally close. Okay. The start stop motor, the normal motor program. Start stop and the latching the motor. You do that. That's what I want to do. So once this one done, we do a small. I give you a project. Just to refresh whatever we learned all this. Okay. Then once we finish this project, then maybe later we can jump to the motor one. So in the meantime, when you do project, I can do the testing. Latching. Save first. Okay, go to the section 1. Now you take the function blocks. Can you see there's a two things, right? One is the instruction, one is the function block.
Yeah.
Okay. You see these function blocks are only available in CP1L. CP1E don't have, no. CP1E don't have. CP1L, CP2E, yeah, they have now. Okay. Then the CP1H, CJ series, all that have. Because it means the higher hand models all that have. The CP1E don't have. Okay, good. Okay, now. You take that function block. So every time you use, you need to give a name lah for the block. Okay, so just put motor control 1. I think no space. Okay, escape. Okay, you bring to center. No, you click here first. Okay, now you bring. Okay, okay. So can you see enable? Right. So you need to enable the block. Okay. So what we do? We take normally open. Put it here. P on. The P on. Always. Okay. Yes. Just control right. Okay. Now at the stop motor, now you put the addresses. So for that you need to choose this. The function block parameter. Yes. Yes. Sure. Okay. 0.00. Okay, you put start M1. M1. Motor. Okay. Then here start M2. Sorry. You escape. Yeah, just double click. Delete 0.02. Sorry, 0.01, right? Okay. You double click. Enter. Okay. Sorry. Stop. Yes, this is stop, right? Stop and move. Okay. Then take one parameter. Yes. Here. No, here. Yes. Moto. So the moto is 100.00. Okay. Enough. Escape. So the enable out only lah. Okay. EM means enable. So enable the function block. Then only the function can work. Okay, we add another one. Put it here. Yeah. Motor control 2. Okay. No problem. Okay. Now, yeah. Again. Okay. Now same thing. You can copy this, put it here. Okay. Okay. Then same thing here. No. Here you put it here. You put the. Sorry, yes. No, cannot copy. Because I want to use a different address. Okay. 0.02. Okay. Start M2. Okay. Then this one is stop M2. So 0.03. Okay. Stop M2. Okay. Then you put one output. Here. 100.01. Okay. Put the name Moto 2. Okay. And this also can put name. Escape, double click, enter. Okay. So you see, you create one logic right here. Then multiple times you can use. But I created for simple one. Okay. You save, download, test this one. Okay. You press stop, the first button stop. That is that. Stop. Okay. The third button. Start. Okay. Fourth one is a stop. No, you haven't downloaded yet. Did you download already? Not yet, right?
Sorry, yeah.
Because the program just now run is in the previous. Got it? You understand the function problem?
It's just very straightforward, right?
Yeah, but not. Okay. Function block is very simple. That is
Stop.
not start stop. You don't program whatever program inside. You don't care lah. Okay. The concept is very simple. Okay. If you have a repeating process. So if you don't want to do a repeating logic, then you can use this. Okay, you do one more. Okay, go offline. The best one, because I can show you. What I can show you is I can show you the internal, the input, output, the external everything. Okay.
Question about.
Yes.
Question is about this Boolean type.
Yes.
So.
Boolean is a bit.
I can change the number here, right?
Yeah, of course. That's what we want to do now.
Bit.
Whatever you want to use, you can use. Okay? Okay. You cancel, okay. You see, what we want to do is, okay, we find difficult in scaling, right?
Boolean is only one bit.
Yes, Boolean one bit.
Integer, they have a 16 bit.
Okay.
INT is a 16 bit, right?
Okay, yes. You see, Boolean is one bit, integer or word, 16 bit, double integer or double word is 32 bit, real, okay, it's a 32 bit as well. Now, what you want to do? You want to do a scaling function in the function block. So I can scale. I have the two this one, right? One is the potential bit. I mean this one. And two analog input, right? This one and this one. Okay, so I can scale from this one. Now, okay, for scaling, you don't care what is the number, okay? So this is the input right now.
Yeah.
Okay, this is the scale value, the output.
Okay.
So normally we call it as a scale value. Okay. Then this one is the x minimum, x maximum, or you can put input minimum, input maximum, the name. So it's up to you. So which one you want to do? Okay. This one is the y minimum, y maximum. Okay. Then we have to do a calculation form to find the rate. Rate is the m. Okay. Okay. you see how many calculation we need to do. That is the delta y. You know the first calculation we did, right?
Yeah.
Then the same thing, we do proper one. Delta x, x max minus x minimum. To subtract, okay. Then to find this one is delta y over delta x. Okay. Okay. So then we have to find out the c. C is offset. Okay, offset is the C. So to find the C, y minimum minus m, the rate x minimum. Okay, it means I need to do this calculation first. Then only I can subtract. Okay, so for the offset we have two calculations. One is the multiply, one is subtract. So you see how many calculations here for now. So first 1, 2, 3, 4, then this whole together is the 5, right? Okay. Then last one is the y equal to mx plus c. So the m multiply x is another calculation. Then these two, this and this calculate addition is another calculation. So total 7 calculations we have. Okay. Let's say we have 5 analog input. We cannot do like this 5 calculation. Or the SCL function also same thing. Because SCL, you put SCL, then you need to move the value, okay, which is going to be bigger. So what we can do one function block, okay, then we can use any.
Actually, like this, for example, they know this scaling function is quite a standard one. Once it's already, whatever they're not correct, they just put in and use it.
That's the SCL function,
Yeah. You can just straight away put in the
SCL.
with the SCL. We have all these formula already, we can use that. Instead of we have to every individual, we have to create our own formula.
Okay, but okay, the thing is they already have the SCL function. We can do, but we are always trapped that because of the BCD binary, right? So if I create my own, right? If I create my own, then I don't need to worry about that.
Yeah.
Because inside the SCL function also, the same thing, they're using the same formula only inside that. Right? But only thing is they're using the BCD binary lah. Sometimes we always, don't like to use that. Okay, we do one because I want to show you how it works. Okay, and we know that, okay, you need to understand here, all these calculation must be in real. Correct? Okay, so we have to have because all these will be in real calculation. Okay. So, but our input, later our analog input will be what? Binary, which is integer, right? Integer. So what we do, we have two conversion. One is integer, or we call it 16-bit, right? Okay, or binary to floating, which is convert the 16-bit to real. Okay, for the input area, the x, right? Okay, then this calculation also will be in real. Okay, this calculation also will be in real, right? Then the y, your output also will be in real. So, but it's up to you lah whether you want to use the real or integer. If you ask me, I want to use integer.
Okay.
You know why? Because I do one block, the same block I can use as for analog input scaling, analog output scaling also I can use the same block. So for analog input, input is the binary. For analog output, output is the binary. Correct? Okay? So there's another one called float binary, which is real to 16-bit. Okay, we do one by one, we do a proper name everything, then we can do.
Okay.
First, you add a function block. Right click, insert function block. Then
So it's just different.
structure text is like a coding.
Okay.
Yes. Okay, you put scaling. Okay. Can remove, yeah. Delete. No, right click. See, like a coding.
Okay.
If, then, else, all that functions. You know, like C++ programming. Okay, go to scaling. Okay, so you need to know all this data we want to do, right? So we need to key in inside here first. What is the input? What is the output? Everything. You go to input. Okay, you add input. No, the enable don't disturb. Right click. Insert variable. Input. Just put input. Okay, and the data type of this input is what? Because I want integer. Want to use integer. Yes. Okay. Okay. Then you put y max, y min, x max, x min. All that real.
Data is
Real. All real. Go to output. In the output, you put the name scale value. Okay, good. Now, okay, input output. So the rest of the things are internal. Go to internal. Okay. The first thing is the delta y, delta x.
real.
That's all real. Okay. Because why? For the calculation, I need this one. But it must be inside the block only. Okay, then the rate. Okay, real also. Then the offset. then okay, then another one is, because you see, like I said, because for the calculation, the x and y, which is input and the scale value, must be in real, correct? Later on only we need to go into convert. Okay, so you put input real. No, go to here, the name, and it insert variable. You put input real, the name. Or you want to use this name also, okay? The x real, y also. Which one you want to use?
Input x, input real.
The x real. I want, because what I want to do here, this one and this one. So I think in x real, okay. In underscore x underscore real. Okay.
So this one for which one?
For this one.
For the x.
For this one, for this input and the scale value. Because all these calculation will be in real only. Okay, later on only we going to convert this. Okay.
Okay. Input x.
Okay. Then another one is the scale y real. Yes. Scale y real. Okay, good. Now, all done, huh? Now we do the calculation. This one make it. No, here. Escape. Can escape. Yeah. You click this. This one, yeah. Bring it up until here. So first we do this calculation. Okay. What do? You click here, normally open the P on. Then we use the subtract, the slash F floating point, right?
Subtract.
Slash F. The always on must be there. F space. Okay. So Y max, you can choose from here. Where is Y max? Okay, then let's put Y max. Y underscore max. Okay, space. Y minimum. Space delta 1. Yes. Okay, good. Okay, anything not clear, let me know. Okay, use this one. Put it here, another one. Same calculation. So just click here, yeah. Slash F. Same. Y x max minus x minimum delta x. Okay. So these two you understand, right?
This one divide, is it? Slash. Sorry. Must be
Subtract, right?
Subtract, right?
Yeah. No. Edit. You click the arrow, cannot. space, space, enter, enter, enter. Yeah, okay. I didn't realize. No, no, escape, escape, escape. You escape, escape first. You click on this. You double click on this. Okay. Now you change the F. Yeah. So you follow the original one. Okay. So this one done, this one done. Now I want to divide. Now divide. Yes. Want to do it here or separate line is up to you. Together, so no problem. Okay, so F. Delta Y. Delta X. The rate. Okay, you add another P on. No P on. Okay. Because this one need to do two calculation. So first, the rate multiply X. So for that, I need to add an internal first. Go to internal. You add one internal. Insert variable. You put just put because M X minimum. M underscore X minimum.
Underscore
X minimum. Okay. Another one is for this also. Just put M. You add another one. M, just put MX. So because you see, I cannot do this the whole calculation. I need to multiply first, then only can subtract. Right? Okay. So we do the multiply first. All floating, eh?
multiply.
Floating. Space. So M is what? The rate, right? The rate multiply X mean. X mean. Need to type. Space. The result is the MX mean. You got it? Not clear, you let me know. Got it? Okay, because you see, I need to do this calculation first. Then only I can subtract with the Y minimum. Because this one subtract, this is like an equation. I cannot do equation.
That cannot be just one shot.
Cannot. One by one only can do. So that is the reason we are doing the function block. Okay? You add here itself. Because we already get this data already, right? So now Y minimum minus this data, I will get the offset. Okay.
So I now wait for
The subtract.
subtract,
Yeah.
and
No. Same, in the same line. You click here. Below this. Because it's the same offset calculation.
okay. What?
Subtract.
F.
Space. Okay. The Y mean minus. So not minus. Space. Okay. MX mean. No, the M underscore X. No, M underscore X. Space. Offset. Offset underscore C. No, okay. Enter. Okay. What do you you do? Go up all the way up. Okay, you just double click here. Double click. Put comment. Calculate delta y and delta x. Okay. Then here, double click. Calculate the rate. Calculate. Okay. Right. Here go down. Okay. Calculate offset. Okay. Okay, go down. So because for offset we need to do two calculation, okay. And this one, the last one also two calculation. Okay, you put a name. Y equal to mx plus c. Okay, just put calculate the y value. Right. Now you add normally open always on. Okay. Now first we need to multiply this first. Then only plus C, right? Okay, multiply. So multiply F.
This one, which one?
Multiply.
Multiply F.
Okay.
So
So M is what? The rate.
M is the rate.
Yes.
M is the what? And S no.
No, the rate. M is the what?
M
Rate.
is the rate. Oh, multiply X.
No, I think what is the name? Rate. You follow your name.
Confused.
Capital space. Okay. So the X is the input, right?
Yeah.
So we already created just now the input X real using this one. Yeah. The in X real.
In X real.
Is this one. This X, right? This one.
Okay.
In X real. You have this one, right? Space. Okay. Because these two need to calculate first. That's why it's going to create an MX. Okay, put MX. Okay. Now you add another line below. Not another line, another calculation. That is the addition. That's why I said 1, 2, 3, 4, 5, 6, 7 calculations. Okay. So the last one will be MX. Last, okay. The MX. The MX plus the C is what? Offset.
C is offset. C.
Yeah. Space equal to your Y.
Y.
No, your Y is what? The scale Y real. You understand this?
Understand? What the purpose is why internal? Why we create internal here?
Okay, that's why I will tell you the one.
Okay.
But the calculation you understand, right? Okay. I know so many calculation. Okay. Now, so you see where is our input here? In this calculation, this is the input, right?
Yes.
And means this is the in X real, and the output is the scale Y real.
Right.
Okay. But our analog is a integers, correct?
Okay.
But in the calculation, I must use real. That's why I created this additional tool. Okay. Why this is in the internal means it will be inside this block only. Okay. Whatever in the input will be only outside the block. That is where we need to key in the data. Okay. So what happened? So it will be, you go to your inputs. Your inputs. Inputs. Yeah. Okay. So this is the one we show here. Okay. No, you see here, see here.
Okay.
You go to your output. Okay. The scale value. Okay. So this is the one going to show here. See, y max is here already to calculate. So delta y, delta x, I don't need to show here. Correct? That's why delta y, delta x is the internal. You go to internal. Internal. Got it? Okay. Then delta y to get the rate, to get the gradient, right? Okay, get the gradient. I need the rate. The rate also I don't need to show here. So it's an internal. If let's say I have an offset like this, so need to calculate the offset. Offset also must be inside the block. That's why it's an internal. Okay. Then okay, why the in real scale y real? Because you see this one and the scale value is in integer, but my calculation all is real. So I create another tool which is input x real, out scale y real. I use this tool to do the calculation. Then later on I convert the data. Okay? Okay? So now we do the convert function. Go down. Yes, you add the name for the number 4. Okay, you put always on. The P on. Okay, so the first one is the input. I want to convert to the in x real. Okay, so my input is in integer, 16-bit, right? I want to convert to real, so it's a float, FLT. Float, FLT. Space. Can you see? It's just now 16-bit to floating. Right? Okay. Your 16-bit is what? The input. Input is the 16-bit, right? Space. The input x real. Enter. Okay, so later in the block we put the AI here, the AI data here. So it will go here, it will convert to this, and this one I use for my calculation. You got it? Yes, because this is the one later. Okay, let's say I complete this one first, then you can understand. Later, this is where I put the 2980, the AI. Then the Y max, let's say I want to scale for temperature for this example, this one. Or for pressure.
You convert for the calculation.
Yes. Because then only here I can put this. If no, let's say if the
Another itself is a bit, right?
It's a 16-bit, it's an integer. You see, if let's say if I'm not using this, the input itself is already a real. Also can, but I cannot put it here. Still, I need to do some conversion, then only I can put it here. Then here I can put like 20 bar, 0 bar, This is 4,000 to 0.
Okay, sorry. Go.
Okay.
Sorry, I will take this. I think ya, sudah sampai ke jalan. Dia dekat mana sekarang? Oke, saya ke orang di sini. Nah, aku maksud sana. Aku mau itu coba kayak sini kalau saya sorry
Okay, good. Okay. Then this is the values we're going to key in later, right? Then the scale value. Okay. Now the other one. Another one is the scale value that is real and convert to my output. Okay. No, you click here first. Okay, then only create space. Okay. This one no. This one is not. This one is because floating to binary, right? Okay. You go here. No, this will be okay. Floating to binary. That is the BCD. BIN is the BCD to binary. Floating to binary, if not mistaken, fix FIX. Okay, I also forget. Fix. Which one? 16-bit to floating is a FLT. You check first. FIX. Space. Another
14 to 16
yes, yes.
You want decimal large?
No, just
That just
okay. So this one will be yeah. Scale Y real. This one. Scale Y space the scale value. Yeah. Yeah, I think that's the name you saved in the output. I think. It's wrong. It's
Oh, correct.
Okay. Okay. Now you done. convert input data integer int to real for calculation. Okay. Can you go to next? I want to add another one. Double. Can you go to down here? You double click here. Yeah. Okay, maybe you give us some space. Yeah. Give some space.
Hello. À, nè, một đây vậy. Khơi, khơi hai biết rồi cả. Chị ạ. Ok, ok. Anh là tanya dia sekarang berarti kita kat mana lah? Dia dia belum sampai lagi kan? Setengah tadi sekarang sudah sampai. Saya juga orang pergi sana sebetulnya tak ada jubahnya. Ya. Saya ada address sudah bagi kan. Saya ada address yang saya pergi sana, bukan pergi yang address yang kamu tak bagi. Apa dia? Ya, tak jauh, dekat juga ya. Suruh dia ikutlah address yang saya bagi. Dia address ini. Ya betul. Dia pergi jalan KBP 5, jalan KBP 5. Ya. Saya kerja betul cinta betul mereka应该还有准备for一个可以抽地方。可以多找我这个空，可以多找我这个。
Save. Now you add one section. Insert section. Yeah. The name goes to the close. You put the block, the function block. AI scale. AI1 underscore AI underscore 1. Okay. Right. You put the always on here. No, P underscore on. AI1. No, don't use the same name. Just put AI1. Okay. Okay. So what is the, let's say I want to do for pressure. So 20 to 0.
Just put a value.
Yes, can put the value.
So just put up.
Really pretty. No. Okay, cancel. Okay, cancel. You take the parameter. Okay. You put here E. E 20.00.
20.
Okay. What I was doing. Maybe the floating point because hashtag is binary, right? Sorry, hashtag is BCD. Correct.
Hashtag is BCD, correct?
The N symbol is binary lah, decimal.
Decimal.
The floating point is a format. It's not it's wrong. You put just put the hash, the N symbol. Where's the N symbol? The N. But you choose the symbol. Yeah, you put the N 20. Okay. Hashtag 20.
If I put F,
No, F.
okay.
Because F becomes a name already. Yeah. Oh, okay. Put plus sign in front.
Plus sign.
20.0. Because need to put the sign lah, plus minus sign for floating point. Plus. Because if you put 0, it becomes channel 0. So you must put the symbol there. Yes. Then the scale value, you put any data register. Let's say D0.
D0.
Because we haven't used any D, right? Okay. Pressure. Okay. Do the same thing for the temperature sensor. So AI underscore 2. Controller.
Separate, so it's supposed to scaling, right?
Oh yeah, scaling. Need to be double click. No, cannot. Delete.
It's not having created a function.
No, already just now I think you created. You just put AI 3. 3 lah. Yeah. Okay. Okay. Now you keep the data somewhere.
How come? Let's say, for example, if I delete save.
No, the FB instance I think is saved somewhere. That's why.
I cannot go back to that other.
Can lah, but I need to check where it's saved. Then let me put. Then follow up like this. Okay. There go. Touch. The laptop is done, is it? Did you save? Oh.
Yeah, I was safe.
I would say both are. But the FB you already saved already, right? Function block saved already.
Still have not.
Save first. Save. Yes. Okay. Now you add all the inputs, the value, everything.
So same like 298,
1, yes. So just put AI 2. Okay. Then what is the Y max? Because it's a temperature, right? So 100. No. Wrong. You must use this. Plus 100. Okay. Okay, then this one is 0.0.
This one.
Okay, then the X max is because that is 4 to 20 milliamp, right?
Yeah.
So 2000. Okay, then this one is the 400. Okay, the output is D1. Okay, wait. Scale value is real, is it?
Yeah.
No, it's an integer. I mean, later inside we go and change. D1. Temperature. Temperature. Okay, because my idea is integer, all this real and this also integer. Go back to the scaling, go to the output, integer. That's why we do the conversion here. Real to integer, scale value, right?
Real floating to integer, right?
So the scale value must be integer.
Scale values is
Integer, right? So you see
Yes.
this is real.
Yeah.
You change to integer. Okay. Alright, save.
Let's say this will affect here.
No. That one won't affect anything then.
What effect?
No, because this one is already a real, right?
Okay.
It's supposed to be this one real, this one integer. But actually, what you put there both real.
Okay. Okay, change it. So we have integer. Integer. Value. Integer. Simple in, upper up, integer.
Okay.
Is that what we put in the number must be the same?
Yeah, it must be integer, the rest is
Internal.
why error? Escape. Click here. Why error? Go to program, compile. Oh, okay. Okay, close.
Right.
Okay, you see definition has been changed. Okay, close. So as we go and change real to integer, right, that's the problem. Okay, you right click here, can update the proprietary update, yeah. Okay. So just okay. Now save, download. Can get the values. What is the version? 20, is it?
Plus 2.
It's 2 only here.
Plus 2.
Then something wrong with our program. Okay, go, you double click here. You close this one. Close this one. Close this one. Okay. Why max minor? Okay, this one. It's max. This one. Okay, go down. Go down. Delta y, delta y. Okay, go down. This one, x minimum is 0. Okay, this one don't have offset lah. Okay, go down. Okay, go down. Okay, go down. Wait. No, here. So your MX, right, plus CC nothing lah, right?
See nothing.
Because this is a 0 lah, right? So 19. So the input is in integer, I convert to real, okay? Because I want to use real in the calculation. Okay? Then 19. Okay, you go to section 2. But why not showing 19? Showing some funny numbers.
This is what? Scaling. This is scaling.
No. You're supposed to show some right number, right? Because inside the program is the number is correct. Double click here. Okay, you see 100. Okay, delta y is 100, right? Okay, this one is 1600. Okay, go down. Go down. Okay. The offset is 25 here, right? See, okay, go down. I mean negative 25 lah. Okay, go down. So mx then plus c I get 26 degree lah, right? So 27 degree I get 27. 26, 27, right? The scale value lah, the output is correct.
How come 27? Oh, the temperature here.
Yes. Okay, you double click section 2. I think the D area just now is different. Okay, go offline. You change to D2 lah. Change to D2. No. What is section 1? Section 2, section 1. So change to D2. I don't want D1. Change to D2. Temperature. So need to reset the memory.
Okay. Oh.
You can see right, 19.
26, 21, 22, 26.
Can because 19 is showing here 19 because, but what is not showing here? No need to change. You click here. Yeah. No. You click here, then uncheck. Why? What is the issue? I mean, the value is correct. You see, supposed to get 19. The value is correct. But here is not showing. Why? You right click here. No, right click. Here.
Property.
Here. Right click here. Empty space here. Right click. Because you know why? Just now what it was real, right? So when it changed to integer, that's why. But the D0 is showing correct value, but only here only not showing the correct value. Because you go to view, window, watch, add D0 here. Double click D0. Okay, change. You see, showing 19 is correct. Oh, okay. Close. Integer, yes. Actually, it's supposed to show in integer, right? But it's showing in real. Because earlier we choose real, that's the problem. Okay, I think need to change this address as well.
Oh, we haven't changed, right? This one. We could forward this one.
Yeah.
Forward.
No. What happened? Earlier this is real.
Okay.
When you put D0,
Yes.
so what happened? D0 become real. Then inside it changed already. This one is already become real. That's why I can't change.
So how?
Need to change the address.
Okay.
Some other address. Go off. No. Wait. Go here. You right click. Online edit. Begin. Communication failure. Okay, right click here. Operating mode. Monitor mode. Yes. Okay, now you do. Online edit. Begin. Change the D0 to D10. Okay. Version.
D10.
Yes.
But we haven't set D10 as well.
No. You right click here. You already send the changes. You send the changes first. Right click. Online edit. Send the changes. Okay. And you will get the value. Okay. Now get the value.
D10.
Yep.
Here is 19, but inside our memory is 30.
No, that one is because in different format, in hexadecimal format. We must see in decimal format because it's an integer one.
Integer is a decimal.
Yes. Okay.
Yeah, zero, so is the zero. If I change that to zero, see how it will be.
No, can. The thing is, earlier because the conflict, like okay, then right click, online click, send changes. Yeah. Okay. Because earlier it's like a format conflict.
Where is the 19 come from?
No, this one because we put 20 to 0 to 20 what?
Yeah.
Now it's a 10 volt, right?
Yeah.
That's why 19.
That is 19, right?
Supposed to get 20 lah. Correct or not? Because our maximum is not 4,000 what? What is your maximum?
This one is
37
the
something.
maximum is 20.
No. Our analog input
Maximum is 4,000.
supposed to get 4,000, right?
Yeah.
But I think I won't get 4,000.
20.
So no, 39 something. So that's why 19. If I get 4,000, same like this, then I will get 20.
Actually, wow, you are so super. Blur here. I know because like I'm worrying about the connection thing, but for you
The
very
connection-
quick, for you very quick, or just move into the program, plug, and working.
No. But the connection you understand. Okay, I mean, take a break. Then after the break, we do a project.
What is the project?
Okay, very simple project. But because what my plan is, want to use whatever we already done. Counter reset DIFD because we don't have any project. So we have interlock and IRC also, right?
How about OUT? The compare first compare what is that?
CNT counter.
Counter the interlock is very simple. You just put the interlock. IL.
Yeah, interlock is just to interlock any program you want to run or something. Okay. So later what we do a project and I want you to include all that. We try to include all.
Okay. Yes. Okay.
And we start one motor run. Heater, then temperature increase, the heater cut off, something like that.
So we not follow about the inside the program.
No, that one is there's no program inside.
Oh.
That one is to show. That one is for Omron sales program, right? It's a step by step how to create HMI, step by step how to create the program, all that.
Actually, there is SCADA meetings. It's kind of
Simulation.
Simulation.
Yeah. Yesterday is yeah.
This is simulation.
Yeah. It's not simulation. It's actually runtime software. It's called runtime.
Runtime.
Yeah, PC runtime.
PC.
Yes.
PC runtime is let's say just in case we don't have the actual.
No, normally SCADA they will use something like this. Only HMI, one PLC, one machine, one HMI. Right. So this HMI to control this PLC to control the machine. So in the HMI you key in all the data. What is the temperature? Everything. SCADA means in the company how many machines have. So all the machines connect to one SCADA. So normally SCADA will be in your control room. They monitor all your values and everything. That is SCADA. So SCADA only can run in PC. So Tellers is like a mini SCADA, which is provided by from the Hako.
So that you have to monitor.
Yes, so Hako they have VSFT for HMI, Tellers is for the SCADA.
So SCADA can control many HMI.
Not HMI, PLC, direct PLC, because SCADA is not connected to HMI. SCADA is preferred.
SCADA that is not connected to PLC.
HMI, direct to PLC. Like that. Same like the HMI, but it's a PC based and bigger scale.
Understood. นี่เลยนะให้ no yeah yeah yes yes yeah yeah nah dulu bagi saya akan suruh dulu bagi MCI sana salah satu saya akan suruh Wong untuk turun barang tu. Okay. Okay. I call. Hey Wong, qua này. What is with the temperature? What is with the temperature? What is...
And
sorry, again. Why the why we using 20 here?
no, because I want to put a pressure.
0.4,000 is actually
The AI,
the AI of
the first one, right?
yeah,
AI of the voltage, correct?
voltage. Yes, voltage. We are using the voltage or ampere.
The first one is the voltage, AI1,
Yeah.
the potential meter.
Oh, this one.
Yes.
Okay.
Okay. Then I want to convert to pressure. That's why I put to 0 to 20. 20 bar, 0 to 20 bar.
0 to 20 bar.
I assume that is the pressure transmitter. The second one, because the second one is a AI2, right?
Yes.
This one is a 4 to 20 milliamp, correct? So it's a 400 to 2000, 0 to 100, which is convert to temperature. The second one, the second step.
We got covered for the second one.
We have two scaling one. One is the AI1, AI2.
So our calculation.
No, calculation only one.
Calculation only one. Calculation only one.
The function block we use 2 times. Yes. One is for the pressure, which is 0 to 2000, 0 to 0 to 20 and 0 to 4000, right?
Actually, this one is using the voltage.
Yes.
The AI is 0.4 to 4,000.
Yes.
This is default, right? Am I right?
Yeah, for voltage.
The voltage default.
Yes.
So this one we are using for
This.
that. This one will be an ampere.
Yeah, yes.
So 2000.
Yes.
It's a 0 to 2000.
Mm.
I think it's 100.
It's a temperature.
Oh, sorry. Why?
Why?
Okay, 0 to 100 temperature. This one you put, this one can put minimum, right? This one is supposed to be 0, but because we put 4.
Yes, so it's for 100.
Okay.
So I do only one calculation. I can use 2 times.
Ah.
Multiple time I can use. For input, output, everything I can use.
Why will be always scaling input?
For input lah. For input, Y is always your scale value lah. The units. Y is always your units, your engineering units. Pressure, temperature, humidity, flow, percentage, all that.
Okay, now got it.
Got it, yeah?
Scaling, because this one is very long. And scaling, you just put one number, straight away you get your result.
Yes.
I have questions for, you have an input, output, and an internal, external. What is the external flow?
External is the what? The external, the physical one? You double click. All the external, if you want to use, here can use. the P on all is the external one, right?
Any specific refer to this one?
The P on, the always on.
This one is clock pulse.
If you want to use that one part, the clock pulse means is that every 1 minute it will be on off, like that.
We can also detect for that low battery. How to detect low battery?
There's a auxiliary there. But we use this in normal section. Use this go to normal section. Go down. Okay, you put normal open. Okay, click that, the low battery. Okay. Yes, then you can create one output. Any output you want to create. Not D. Any physical output, or you want to use a memory also can. Okay. 100 dot what? 01 already used. 03 lah. Something like this.
But how to detect low battery from the data?
Yeah, if the battery is low, automatically it will on.
I see.
No, I know because of the calculation. Whenever I teach calculation, of course. Okay, good. Okay. So what we do now, we do control shift. But we try to use all. Cannot use all, that's the problem. But use all the function, then it must be a bigger program. Okay? So I try to use the function, okay, normally open on close point, timer, then the compare, the scale, the analog function. So of course analog function we have a compare, right? Compare the max, okay, it's up to you. The function block also is up to you whether you want to use function block or that. So when I start one conveyor on, when I start, okay, let's say this one is a chamber, okay, a chamber. So I want to maintain the temperature in the chamber, okay, for example. So what we do, because I also thinking of doing project. Let's say we have a chamber like this, okay. Then we have a heater inside and heating and okay, just like normal output lah. The heater, okay. Then so once I start, the heater will start to heat. Then we don't use this temperature one. Okay. There's a temperature transmitter to detect what is the temperature of this one. Okay. Start the heater on. Okay. Then when the heater on, temperature start to this one. Okay. Heater on. No. Okay. Let's say I have a fan here. Okay. Fan or exhaust fan, something like fan here. Okay. So when I start, the fan will on first. After 5 seconds, then heater start to on. Then fan, of course the fan running. The heater also on because I want to circulate the heat to all up. Then the temperature when I reach certain value set point, then what happen? I will on this one is the for in fan, this one for the output fan. Once I reach a certain level of temperature, then the output fan. Okay, so it will release all the. So it means it will like this. So whatever heat, so the temperature will decrease. And temperature decrease, then whatever output fan will off. Then temperature increase again. So it increase, decrease, increase, decrease. Then once when I press off, then all off. Okay. So what we do? Start, stop. Okay. So the input we have a start, stop. So we can use 0.0, 0.1. Okay. Then our analog, the DD, right? The AI, the DD temperature is at 2980. Okay. Then for output, we have the in fan, the out fan, and the heater. Okay. So of course you need to do one scaling. So when you do scaling, of course you need to use compare. First need to do. So of course you will use normally open, normally close, time coil, timer, set reset is up to you. Whether you want to use coil or set reset. Differentiate up, differentiate down, depend. If needed, we'll use the pulse. Counter no need. Of course compare is there. Mathematics is depend on you whether you want to use the SCL function or your own max function. Okay. Then move function. Okay. Function block also is up to you whether you want to use function block or just normal program. Okay. The project is when I start. Okay. When I start, I make sure the temperature is less than 30 degree. So I need to do comparison first. Okay. Then only I can start the process. If no means I wait until I reach 30, below 30 then only I can start. Okay. Start. The in fan is on. Okay. Then run for timer 0, 10 seconds. Okay. Once timer done, the heater on. Okay. The heater on. So heater on, the temperature will start to rise, right? Okay. So when the temperature is more or equal to 50. Okay. Okay, the heater I want to off. Heater I want to off. immediately so then once the temperature less equal to 40, then the heater on back, the out it means you see when temperature is 1, okay, the output fan will off, right? And heater on back, right? Correct. It means my process go back to here. Then repeat. So heater on, temperature increase, heater off, output fan on. When temperature decrease, output fan off, heater on. So just repeat only. Okay. Then when I stop, the in fan, the out fan, and the heater all off. Okay, can? Okay, try. Okay, try. So you can one. So but need to do scaling, right? Maybe scaling you do in another section.
Scaling and section.
Yes.
two programs together, right? Need to close one file with that program.
No, can. So what do you do? So this one is for the new project, right?
Oh, it's just one.
This one, okay. You just save it. You just open this one. Minimize. No, not that minimize. Minimize the whole sales program. Yes. Open another sales program. Yes. Then you can click on it. Because in the same sales program you cannot open two. You must have two sales programs.
Timothy.
Timothy, right? If he comes, just ask him to refer.
The HMI, the PLC also, right?
Yeah, PLC and the power supply is ours. Yeah, and the cable is different.
So can I compare with the temperature less than 30%? What functions are these used?
The compare function.
Compare functions
This.
less than 30. Compare function with temperature.
Okay. First, you need to have temperature first.
Yes.
You already say after scaling lah. Right. After the scaling, you will have a temperature.
Correct.
So, temperature. Let's say you put the temperature inside D10. Okay. Example D10 is the temperature. So you want to compare, and if it is integer, just compare greater or less than. For example, the first one,
I need to have a temperature first, right?
first temperature first. Then okay, less than.
I need to have a temperature stored in the value digital first, then only can compare.
Yes. Because now 2980. What 30 degree means what is the value?
30 degree means
0 to 4000. 30 degree means what is the value?
yeah.
You don't know.
Yeah.
So do the scaling first. Okay. Then let's say the D10, right? Okay. Then if it is integer, 30. If it is floating, F. D10 plus 30.0. So do the scaling first.
Okay. Floating.
Depend of your scaling result. How you want to do scaling.
data with compare, right?
Okay, correct.
Is there we put the is there any
No need, there's two only.
is there anything more with the question?
No,
D10
no.
supposed to be the last one or
No, no, D10 first.
D10 first, right?
Okay, and then okay. Okay. Right. D10 is the temperature, right? Yes, correct. No, because need to be something at the back. Not at the back. That one is the interlock. Okay. What is that? Our compare function, right? Is similar to normally open or normally close. Always in front. So it must have something at the back to complete. So let's say you want to you can put it here, okay, or you want to put it down there also can. You can put it. Then from this I create a memory. You can use the holding bit or the work memory. Then later on for your process you can use that memory.
Depends on why I need to use another memory or not.
Yes, better use memory lah. So you can learn about the memory also. Means like this lah, right? So let's actually for compare no need the always on. No need. Let's say okay. Let's say
Just compare and
yeah, let's compare D10 with the 30. So W0. Okay. Then this name you can put okay name name one name. Temperature less than 30. Any name like this. Then this one you can use anywhere you want. So this project will be like a complete project. Like you will have a normally open, normally close, the timer, the memory, everything.
Use the W. We use the W.
What you use W also can, holding H also can.
D.
D cannot. D is a value. D always value.
W is not value. The temperature is not value.
You know what I mean? D is the always value. Here the coil. Coil must be always what you need to put? Boolean. So Boolean means what I can accept. Channel bit, work bit, holding bit.
D is a value.
It's a the output, right? It's a Boolean bit. Only can accept bits. Data register is a value. Like an integer, double integer, all that we use data register.
Only data register is value, right?
Yes.
The rest is the boolean.
Check. No, there's a thing. Okay. You see. Can I erase this part?
Yes.
Can I?
Yes.
This part.
Yes.
You see. You see channel. Okay, let me put like this again. Because channel is always the number, right? So we confuse. That's why I put channel. Channel. Okay. 0. W0. H0, D0, okay, means 16 feet. Correct? So if 0.00, W 0.00, H 0.00 is a Boolean, which is 1 bit. But D 0.0 we don't use because D always only 16 bit only. Okay? The channel, the work bit, the holding can be used as 16 bit to store value or can use as a Boolean. Okay? But normally what we do, we use data register to store values. Then the channel, the work bit, holding bit to store the bit value 1 or 0. Because why? Data register, if you have battery, it can keep the value. Because the value, if you store anywhere here, channel, work bit, once you power off and on, the value becomes 0. Only the data register, when you off and on, still can keep the value. That's why the value always go to the data register. Okay?
But for example, now we have this after do the comparison
Mm.
temperature. So it goes to like work order, big.
Yes.
That one big one is not the data anymore. That one is just a signal.
Yes, okay. The thing is very simple. Actually, both are data. Both can keep value. The thing is, this one can keep value only 0, 1. This one can keep value 16-bit value. That's all.
Like you keep the address into the right? No.
Yeah, you mean this one, right? Okay, what I'm doing here is I compare it.
Yes.
I compare it. I take the result
Yes.
of the compare. I put inside a
So basically it's on or off. It is
yes,
correct
yes,
or not, right?
yes.
Info.
It's like on-off signal. I put inside the W.
Oh, true. must be the BCD. This can be
You want to use BCD also can? You want to use binary also?
both also can.
You want to use TIM also can? TIMX also can.
Or TMS is
Binary.
binary.
The numbering format lah binary. Okay.
That. Yeah, you go have a rest.
Just doing the setting and set up this one. That. Go for it. Good bus.
Yes, no problem.
You can do that, no problem.
Got you here, no problem.
Is it?
Got you here, no problem.
No, the thing is,
You don't have to troubleshoot.
yeah, one thing I know of is because I never done this with Omron. I done this with last time with Siemens. So I just checking all the manuals.
Another thing I saw you have an internet EtherCAT. What is an EtherCAT here? EtherCAT is another.
It's similar like Ethernet, much more faster.
Oh, it most like Ethernet EtherCAT, but the port
Same
or
like
same like Ethernet. The wiring is same like
everything
Ethernet.
is same like Ethernet.
Okay.
IP address, everything. But it's like they just give a new name, new protocol. So which is speed, more higher speed. So because they have some EtherCAT, they call it EtherCAT IO link. It means you connect there, then there will be like IO link, like a switch, like Ethernet switch. But it won't be like Ethernet, it will be round port. So some special sensors, which the sensor can support EtherCAT, can connect to the link. So no wiring, all communication. Yeah, all communication. So
So we just
sensor must be like intelligent sensor. lah.
So means that you still using the Ethernet cable.
Yes.
Connect to that one.
Yes.
But make sure the instrument they have another interconnect.
Interconnect, must support interconnect.
Must support interconnect.
Yes.
With an additional card lah.
Yes.
Like what I showed you a CCD the card. They
Yes.
have a port.
Correct.
Ah.
Because interconnect is, not mistaken.
Then no need any programming. Programming still
No,
using the
programming
PLC.
is same.
Still is PLC. PLC just have one feature to connect to the
Yes,
card.
everything is same. Just like but it's like configuration, like no
No configuration, no physical.
So you need to tell, okay, you need to tell at the interconnect, okay, I add these cards, these are the modules, all that. So when you add, that's the thing, when you do configurations, the PLC will already get the addresses. So it's easy to program, not like Modbus. Modbus, you need no configuration. So you need to check what is the manual here for the addresses, then only we can get the address. So for example, so can I have this?
Take one first.
Yes.
Take one. Okay.
Okay. You see, very simple. All these interconnect, all these right. In the software, let's say this is the PLC, okay, this is the Ethernet port. There will be a software to do the what they call configurations. Means okay, you need to tell this PLC, okay, I connected a module, any module, okay, let's say VFD, using Ethernet. Okay. So whatever in the PLC, you already get all the VFD data. So the speed setting, everything. So for an example, okay, when you connect in the software itself, it will show you, okay, let's say for example, channel 200. Channel 200 is for the command, start, stop command, for example. Channel 201 is for the speed command. Channel 202 is the speed feedback. So you already get this data. Straight away you get it. Once you do the configuration, once the configuration done, you already get the data. So just do the program like normal. Modbus is, so Modbus you cannot do this configuration because Modbus, I don't know what is my device. The PLC, in this case, the PLC will know what is the device, VFD, what model, is it Omron, is it Mitsubishi, is it Siemens, everything it will know, the PLC will know. In Modbus, they don't know. So, same configuration only. VFD, let's say I'm using the Ethernet, but this one now is an Ethernet, but it's a they're using Modbus protocol, okay? Now, I don't know what is the VFD. What I do, I will do a command, do a programming to read the Modbus data. So, when you follow the PLC, this PLC will tell you, okay, D1300 is the set point, the baud rate. D1301 is the ID, because this one is 1, 2, 3, right? The ID number, so something like that. You need to set everything, then you need to tell. Okay, then in some command, okay, it will be the 305. Okay, is that the command? What command you want to send to the drive? Then the drive will send you back the data. So something that means additional programming is. That is the difference between you using their existing configuration or Modbus. Later we will. Now I'm just preparing the manual.
Okay.
So later I can give you the manual so you can get an idea. Yes. Just need to do some
operator, I want to ask, for the comparison for all these kind of functions details, is that all the values, which one is they are focused on BCD, right? They are
Compare.
only compares the BCD.
Oh, you mean the big when you use BCD? Timer, counter, and the SCL function.
SCL function.
Mm.
The other one is all you
Binary, normal.
Okay, timer, and compare timer and
SCL.
SCL. Unless the timer I want to use a TIMX will be binary.
Yes.
Compare. But for the compare, my here is put as a decimal instead of my comparison is put as a decimal instead of integer instead of BCD.
Mm-hmm. The compare is BCD.
Like for example, this kind of comparison functions,
Mm-hmm.
instruction I put as a
Binary.
binary. But you say the compare usually for BCD.
No, compare. Counter.
Oh, counter.
Yes.
Mm.
Counter time.
Yes.
Yes.
Counter. say we have this file. It's like, for example, we have all this file. You know, they say is it top
The backup in OPD cannot read.
cannot
No need.
can delete, right?
Can delete, yes. It's a backup file, mate.
And then one more. This one, how to see that?
No, because you remove this. That's why I
This is a program for this one. let's say for example the program, some session I just want to not to read that, so I just want to disable so not to read. So
Interlock.
just use the interlock. I think like for example, I just want to make a remark as well. I just want to make a remark, I don't want to read the programs.
Yeah.
Just use the
Just can use interlock.
Can I use a reset to reset the counter? Because they have timer.
What's it?
Can I use a reset to reset the timer?
Reset.
Reset
Reset the timer.
Set and reset.
Timer. Can?
Why?
Timer cannot set reset.
I tried this one, error.
Error. Yeah, because you know why? Because if you want to on a timer, this is the one. If you on, timer will start to count. Once the timer finish, let's say this one right, T0 will on. If this one off, timer will automatically reset. So if you want to off the timer, you need to think how to off this line.
Yeah, that's why I'm thinking. I use a W to off it.
Cannot also. Cannot also.
That's why I got the one account.
Oh, because of that.
Yeah.
Cannot. You delete that. That is okay. But where is the T for T0 you put?
This one?
But how is T0?
That's
cut this one. Okay, you see, here cannot cut, you separate the time.
Because your condition is start and that time, start and temperature.
Start temperature, yes.
What?
Why you want to cut off the timer?
Otherwise, the timer will be activate.
Keep on activate.
Yeah.
So what happened?
Nothing happen. But you want to reset also, right? Otherwise, the timer will be always on.
But when you stop,
Of course, correct.
then it's okay. Not necessary to turn. Okay, put less than 30. Okay. Start. Okay. Go down. Okay, go down. Okay. Now is it heated on? No, heater. Okay, first.
The amount is after the timer.
But it's not on after the timer.
On.
What after the timer is it? Okay, then. Macam mana? Start. Leave this value baby. Go down. Okay. Then when the temperature more than your
15%. 5.
so output fan on, input fan on. Less than
Less than 30. Less than
50 is on already.
Less than 5.
Yeah, but less than 50 lah, right?
Yeah. Less than 50. Less than 50.
But it's supposed to be less than 40, then only it will on back. Right? This one on, but the heater is already on. Right? You see, 250 into half, still 50, 49 degree. Heater on already.
Equal to 50. Equal to 15.
Yeah, equal to 50, it off. Correct. Temperature 50, okay. It off, output fan on. Less than 40, then only the output fan off. So the output fan will be still on. See? Fan on, heater is still off. When I go below 40, then only the heater on. But now at 50, below 40, it off.
The looping, I need to do anything. The loop,
No need, but in the programming, you need to do.
I have to do something.
Yes.
How to do the loop?
No, don't think of loop. Don't think of loop. What I mean is, you see why I put this one, I don't want you to do this program. That is, who on the timer? Who on the heater?
Who on the heater is the
T0?
T0 after the timer.
Heater, right?
Temperature below 30.
Okay. Timer on the heater. Why I put like this? Because the process repeat. It means first time timer will on. Second time is the less than 40 need to on back. So what you need to do?
Is the 30, 35.
The less than 40, right? Create a memory, right? W0.5 for example. It means need to off the fan.
Yes, off
Right.
already.
So let's say I have some
Yes, on the fan.
the fan, out fan. So need to off, right? And why I put it here?
And also on the heater.
On the heater means on the heater. So if the timer is always on, use the pulse. Make the timer as a pulse.
Use the fan as a
Use the DIFU.
DIFU.
Yes.
Yeah, I do. Or I use the
Okay, if you want to use this pulse also can.
If I use the timer W.
No, wait.
If I give you the address W and
This timer. But still the timer need to on the heater, right?
still the timing behind it.
I mean, first time timer need to on the heater.
Correct.
Second time the W need to
Yes,
on.
Yes.
So this one must be put in there.
Yeah. Yes, W. Yes.
Yes.
Correct.
But this D is always on.
Yes.
But you don't want always on.
Yeah.
You want to have a pulse, right?
Yeah.
Means it's like one pulse only. Then you see. Now it's like this kind of.
Okay.
Wait. You see. Now it's like this.
Yeah.
So I want to. This is the temperature less than 40, right? Here I put something that is temperature more than 50. Right. Very simple. Timer on the heater, more than 50 cut off, less than 40 on back.
Okay.
Alright. This timer is the one always on. So I on the heater. After 50 I off, but I go below 50, 49 I on back the heater. Correct? Why? Because this one. So this one is always on. I want to off this. Cannot, because on top is a timer. So I make this as a pulse. Means this is normal right? You can put like this one. I will show you how to put. Means this one means when the timer is energized, I just give one pulse only. So what I do, heater cannot hold one pulse. So I latch the heater. So now it's like push button. How to put this one is, you choose this place, click shift, alias. Go apply. Go down. Is it number? Okay. Yes. So this one off back, this one ready, right? So it's correct. So this timer make it pass. Shift, no. Choose that shift 2 or the alias. Yes. So now it become pass. So now we need to latch the heater. Latch the heater. Yes.
Also the temperature.
Yes. Temperature less than 40. W050. Yes.
This one.
No, that one is needed.
You say DIF.
No. Because you already used the pulse already. So don't need DIF. Now you test.
I need to check how the DIF.
DIF, okay. Very simple. You see here. You see here. I can use this pulse like this, or I use the T0, DIFU, W10.0. Now instead of using T0, I use W10.0. It's the same thing. Mean from the timer I create a differentiate up, I use the differentiate up. Okay? Instead of using this, I can straight away use the T0. So both also can.
DIF for what function?
Differentiate up, it means, you see, this one is always on, right?
Correct.
So the moment it's on, the W10.0 become a pulse. On off, that's all. Finish. The next time the T0 is on, then only I will on off.
Okay, let's say DIFD.
Is a when I on, nothing will happen. When I off, then only give pulse.
Proceed.
Yes.
Right. good.
You stop. Okay, go down. You close this one. Okay, go down.
Because otherwise the OBP turn off.
Okay, no, no. You go up. Okay, go down. Okay, start. Okay, go down. Okay, leave it. Okay, hit the on already.
Either out because of full condition, what in and off. This one below 40 should turn on already.
Yeah, that's why. But you can use this way. What?
Huh?
Why you don't want to use this way?
In this way, I just now use also, when you keep turn on also, need to cut somewhere, you know. Because
Okay, you go more than 50.
because just now, let's say for example, I use your method,
Never. You go more than 50.
more than 50.
Okay, way down. Okay. Less than 50. It's already on the heater. Correct.
Less than 50.
Less than more than 50, heater off. Okay. So less than 50 is supposed not to on. Less than 40, then only need to on. Correct.
Okay. Less than more than 50, less than 50 is still on. It's still on, right? Less than 50, the heater is still on, right?
No. Less than 40 only on back. Can you see?
Okay.
So, okay, go offline. I will arrange the program correctly. Go up. Okay, go down. Actually, yeah, this one, right? You add another section. Okay, close. You right click here. No, right click here. Right click. Cut. Okay, you go to section 2. Okay, right click at the side here. Paste. So we just leave it here. Okay, go to section 1. Okay, go up. And yeah. Now what do you do? In front of this, you right click, insert column. Okay. So when I start the fan on, right?
Yeah.
I use the fan here, normally open. I just arranging your program, not changing your program. I just add 100.00. Okay. Escape. You click here. No, click here. Control down. Control down. Okay. Go down here. No, go down here. No, down. Scroll down. No, just put no. Okay, temperature. Okay. Click right click here, paste. Okay. Same. Control down. Control down. Okay, go down. Same. This entire line. I just put all in one line. Okay. Right click, cut. No. Put it here. Okay. This one can have it. Okay. Now, number 3 can delete the thing on it. Okay, go up. Now, because less than 30, right, I cannot use the fan to compare, right? So you change this to always on. Double click, change to always on. Delete. Okay. LD is correct. LD is correct. Space P underscore ON. Sorry, choose this. Yes, okay. For these two, you can put this interlock for the 50 and the 40. Because 50 and 40, when the fan is input fan is on, then only can increase it. Then you can put interlock. Can't copy, put it here. Okay. Now I just didn't do anything. I just arrange in one place. Okay. Go down. Now we just play with these numbers. Okay. The timer is done. You see, timer done. Heater on. Okay. Good. Clear. Okay. Then more than 50, heater off. Okay. Then heater off, out fan on. Okay, good. Okay. Out fan, so the fan will be still on until 40. Okay, what you do? Did you do one by one test or you do everything then test?
Everything does.
Yes, that's the problem. Okay? Okay. So according to this, I say the timer, no, don't delete anything. Timer on the heater, correct? Temperature cut off, correct? Heater off, right?
Yeah.
Okay, these two can take out.
Yeah, this one too.
Okay. Then when more than 50, okay, on. When less than 40, off. Okay, turn it. Okay. This is according to this line. The repeat later we do. Once we confirm this first.
Yeah, confirm already. Actually, this confirm just only the thing.
No, not confirm.
Not confirm.
I will tell you why. Okay, save, download. Okay, then close. Close this one. Okay. Start. Okay, less than 30 first.
That's this one.
Okay, enough. Okay, start. Okay, go down. Go down. We just monitor here. Okay.
Heater on.
Heater on already. You increase the temperature.
Up to 50.
Okay,
50.
good.
Yeah.
Okay. Until here done.
Top fan is turned on.
Until here done already.
Yes.
Okay. Now, you go below 50.
Now below 50, turn on.
Okay, heater we don't get. But why the fan turn off?
The fan.
Fan supposed to must be on until below 40, right?
Yeah.
Correct. So now it's off already. So what I need to do? Need to latch it.
Latch it.
So what you do? You right click here. No, right click here. We do online edit. Click here. Put it here. Normally open. 100.01. Okay. Okay. Control up. Okay. Escape. Right click, send changes. Automatically send changes. Okay. Now stop. Stop. Okay. Again. Put less than 30. Okay. Start.
Oh, you can see the value.
Yeah. Start. Okay. More than 30. Still on. Okay. Increase. More than 15. Okay. Fan on. Okay. Now go below 50. Okay. Fan is still on. Heater we don't care first. Fan is still on. Go below 40. Fan off already.
Below 40.
Fan off already.
Yeah.
Below 40, fan off already. Okay? Good? Okay. Now, the heater. Okay, why? You go above 50.
Above 50.
Off already, right? Go below 50.
Okay, 50.
On back already.
It's
Supposed to go below 40, then only on. Right? Correct?
Okay.
So, in that case, you right click here. So now, because of the timer, because timer is always on, but okay, we make the timer into a pulse. Okay, edit, online edit. Okay, make it the pulse, shift, yes. So this one pulse, so I cannot always give the signal here. So I latch the meter. Latch the meter. Okay. So now I cannot automatically on that. Okay, I wait. Then who need to on? Temperature less 40, right? Okay. Go offline. Okay, I can put you. Yes. Less than 40 is what? W0.3. Okay. Alright. So the timer gives just one pulse only. The initial on, that's all. Right? Because initial on only I need the timer. Then hit the on. After that I use this one to on off. This one will on, this one will off. This one on, this one off. Okay, you try. Escape, send changes. Okay. See, hit on, right? Okay, more than 50.
No, even you see, haven't start anything.
You stop first.
I stop already. I haven't start anything.
Nothing on.
Straight away later on already. It's supposed to go through timer to take over.
Oh, okay,
Because
okay.
it keep activate. Because
Okay, no
less
problem.
than 40.
Because of this one, right?
Yes.
Because of this one. Okay, okay, good, no problem. Then for this you can put a condition.
So I just not put a condition.
No, that condition is still the same thing. The fan, right? You put the fan, right?
Yeah.
Just now you put this and this one here.
Mm.
The same thing only. Okay. What you do? Instead of that one, okay, you go. You stop first. Okay. You click here. Edit. Okay. You right click here. Insert column. Column edit here. Insert column. Instead of you put the timer as the interlock, because once the timer is reached, then only I can repeat. So you can use the timer as interlock. Put T on T0. Okay. Put T0.
Okay, now should be okay.
How is it? Start. Okay, you see it's not on, but I wait for the timer. Okay, but we still need to check. Okay, more than 50.
More than 50.
Okay, less than 50.
Less than 50.
Okay, you see 49 still not on. Can you see?
Yes.
Just now earlier 49, 48 all on already, right? The heater.
Yes.
Okay. Now you go below 40,
Below 40 we turn on.
only turn on. Okay. Then go above 50,
Above 40.
nothing. Above 40 still same. It will increase until 50. Cut off. Fan on. Okay. Go below 40.
Go below 40. The heater still off.
Yes. Heater on. Fan off. Then when you stop,
All shut.
yes, all off. Good?
But this one no need to kill, right?
No need to.
To kill off the timer.
No need to. Because this is like a condition. Once I done, I reach 10 seconds, okay. Because
Just,
I'm
just
using
water, no need to kill it off.
yes, because that timer is the one is the give the next command. Because this timer must be on, right?
Yeah.
Then only I can repeat.
Okay.
Repeat. Any question until here?
No.
Know what? So you know how to use timer, know how to use compact. Okay? The logic no problem. Okay, the logic is no problem. The most important thing is not need to know how to, of course, how to download and for the training, right? How to download, upload, how to use the addressing, when to use the 0, when to use the 100.0, when to use the W, when to use the data register, how to use the compare, timer, calculation, everything. So this calculation you do, you just copy from there, right?
Yes, correct.
No, but you understand, right? How to do that's the most important.
Understand.
Okay?
Why you do this? I think about.
No, what you do this means you need a lot of time, you can write down first, then only can. Because you see, it is difficult to see like this, but if I write down in a
Paper.
in a paper, it's easy to understand. Because of the visual, right? It's a block.
One.
Okay? Now what you do HMI for this.
HMI for this.
Yes. So simple HMI only. First, let's see, first list down what you want to do.
It's actually refer to the input output here.
Start stop first, okay? Start stop first, then the in fan,
Fan,
out fan, okay? Then another one is the temperature value. That's all. That's it. Okay?
okay.
Do first. This one.
Forgot now.
Huh?
Forgot now. Okay. Wait, okay.
First thing what we need to do.
First thing we have to go to
HMI. No.
no.
No HMI. First thing what we need to do. Okay. First we need to decide first what is the addresses. Okay. This one is 100.00, right? 100.01. Okay. Cut fan is 01 or heater 01?
Cafe is 01. Heater is 03. 2.
Okay. Then your temperature is what? D?
Temperature D10.
Okay. And your temperature is what data? It's a decimal, right? Binary, right?
Then binary.
Okay. That's okay. Then start stop. What is the address?
Start stop is the 001, 002.
Can I use 001, 002?
No,
For HMI?
W.
Right. Okay. What W you want to use? Because some W I already used already. Correct. Right? Some W I already used. So I use the other W. So I can start with W10. So I don't want to catch out the other W lah, right? Just put 10.0, 10.1. So I need to do what with this?
We have to create the start to this W.
Yes. Not start to the W. You need to add the start button. Wherever you use the start button, need to put the start button.
Yeah, we
Need to add.
need to add
So you need to add.
to the output lah.
No, not to the output. Like this. You see? 0.00. Start, right?
Correct.
Okay, whatever I don't get.
Hmm.
So I need to add W10.0. Remember?
Okay.
Then once done, then only we can do the HMI.
CP1, CP1L.
Using Ethernet. Use Ethernet.
Yeah, I use Ethernet by itself. I really select the cabling connected to this PLC.
Double click Ethernet. Add. Choose PLC.
Oh, I go to PLC.
No, your PLC idea is
Here got the training.
not here in Malaysia. Our normal by default is one.
Okay, all.
Yeah.
You cannot, if they train the PLC, I can press the warning capture.
Can change. Okay. Station number.
One is that one. Oh, no, sorry, 10.
Double click. Stay on any 10. Okay. Add. PLC. Okay, what ID? Okay,
What is that?
what ID is the last number?
The last one. The last one.
The last number one. Must be same, no IDs.
Okay.
Okay. Okay. Yes. Okay. So now what? Fault.
Done. The area LW, it's okay, right? LW, area of variable.
No. This. Let's choose these addresses. The area of variables.
Yeah, because they let you choose LW, RW,
W,
Only the border.
which one? Ah, click there. Go down. Right? No, common, not common button. Take big button. Go down, go down, go down. Go down, go down. Right? Choose PLC. Choose big button. Choose PLC. Cancel, cancel. Go back to the DFF project.
I'll just put an address here.
No, no, cannot. It's not showing the PLC. Showing the PLC. Create new file. Put it in.
Okay, right.
Yeah. Okay, let's save asset. We save in the original folder. It become in it will save under program file, Omron, and be here. Okay. Let me save here. Okay. Go to PT 01 total. Then PLC is
Serial.
Omron CP1 LEMEL. Okay, all these are.
Okay.
Then go to connector. And 20.
Yeah.
10.
So,
10. Okay. Oh, I think just now you didn't choose this.
yes, I not choose it. What's the CP?
CP series, isn't it? Okay. Original is the CJ series. You need to choose CP series. That's the right thing. That's right.
Oh, right.
Ah, sorry. Must have this number. Earlier don't have number, right? Now, yeah. See the WP all got.
We're using a group, right?
Yeah, you're using W, right? The button.
Mm.
So use that. I think just now you didn't select the CP.
I see. Configuration. lab is a CIO big, right? Lab,
Hmm?
lab will be CIO.
Yeah.
Test label.
ABC.
Oh, the text. Okay.
No response for the stop button, but temperature got response.
What's that?
Below 20. Okay.
Okay, because I think it will change momentary.
Oh, momentary.
Correct.
Correct. She said.
How I know? You go to your program. I see the V10.0 always on.
The setting up for everything.
Yes. Go and check. Go to PLC. Transfer. Compare. Compare. Okay. Fail. Okay, click the first one. Yes. The W you add, you haven't downloaded. You see it. Run this one can run. No, but online
bus.
Finding that work.
Yes.
all these things. Hello, all okay, yeah?
Okay.
You remove this? Bring this. Pins lah. RJ45 they have 8 pins. So pin number, yeah, the blue color pin number 4 and pin number 5. Okay. So 4 is the positive, 5 is negative according to this manual lah. So here I follow lah. A negative to negative. I mark already here negative, right? Then positive to positive. The ground I connect to the ground because this number 16 is the ground. Can you see?
Okay.
Why I use resistor? Because for these two, right, need to have in between must have 120 ohm according to the manual. Okay, so that's why I use this. Just modify because if I have only 120 ohm, I just can put it here. So I don't have 120 ohm. So this one is 100. Okay, 100 ohm. This one is all, can you see, all 100 also, but in parallel. If it is parallel, it will become 20 ohm. So 100 plus 20 are 120 ohm. According to the manual lah, you need to do this at this side. Okay.
I think also can.
Huh?
I think also can. Surprised they need to.
Because in series
Yeah,
is plus.
But I'm surprised they need the resistance in between.
Okay, why? Because they need to know this is the first. Okay. If I have multiple drives, like this multiple drives, so then from here it will jump. Okay. The last one must have this. The first and the last one must have. Since there's only one, so just need one side enough. If I have multiple, first and the last must have.
So in actual the cable, okay, because this one you modify yourself, but in actual the cable is how is it like without with the resistor, or every time they still need to modify the cable.
Yes, no need to modify the cable. Or they buy a special connector lah, that's come with the resistor.
Is that there's a manual mentions about the resistor?
What in the manual?
Yeah.
Yeah. That's why I put 120. I will show all the manual resistors.
Surprise. Just kind of a connection.
Okay. There's a lot of surprise.
If let's say, yeah, there was they, if let's say they do not have a resistor, what will happen?
You cannot communicate.
Cannot communicate. How? Okay. So USB port.
Okay. Now, all flags begin. Open. Okay. First thing is, okay, very bigger. So this is the wiring of the drive. Okay. If you are using analog to for the set the speed and digital to on off, you will be using the terminals. Okay. Clear? You will be using the terminals.
Okay.
So from my PLC analog output, right? This analog output, right? Output, go and connect here. Pin number what? Number 12 and the number 13. Okay. Sorry. 0 to 10 volt. 13 and 14 common. Yeah. So 13 and 14 is 0 to 10 volt. 14 and 15 is 4 to 20 milliamp. Analog means my PLC send the analog value here at the 13, 14. Okay?
13 and 15.
No, 13 and 14. 14 is the common.
Okay.
13 is the positive, 14 is the negative lah.
This is analog signal.
The analog signal lah. Then the start forward, here number 2. Here. So there will be, so the output, my PLC output can connect here. Forward and the direction. Okay? The output, that normal output lah, can connect here. That if I am using the terminals. Okay? So now I am using the RS485. Okay? Okay, so for RS485, they already tell you that, can you see? Number 1 and 11 need to loop. Okay? So I have already looped ready. Go down. And you see, can you see the RS485? The shield, they connect number 16. Can you see?
Yeah.
Number 16. So that's why the SG, the ground, I connect number 16.
But did you mention about the ground?
No. Can you see? The RS485 shield is the ground. Can you see? This is
ground.
ground. This is ground.
Okay.
Okay, go down. Scroll down. Okay, go down. Slowly go down. Okay, there. Okay. Now, you see the master. Okay, master is means your PLC lah. Okay, you see power flags 4M. Pin number 4 and pin number 5 from here. Okay, from the RJ45. Can you see they put 120 ohm resistance?
Yes. Well, that's more.
Across. Let's put across. Okay.
And here also.
Yes, if you're using multiple, Okay, make it smaller. Go down. So this is the one if you're using multiple, right? Okay. Okay. So the most important commands is here.
This is RS485, the cable manual.
Not the cable manual. From the power flex manual.
What is power flex?
Power flex is the HMI. I mean the drive.
The drive.
Yes, the drive. The drive name is the power flex. Elementary one. Okay. The power flex manual. I only take the this portion only. The full manual is there. Another one. Okay. Go down. Okay. So supported Modbus function code. Okay. So first we need to understand what is Modbus. Okay. So Modbus is something, a connection like, okay, this Omron, I cannot directly connect to this AV drive to send command. There's no direct connections, cannot. So it's not like Ethernet. I have Ethernet, you have Ethernet, direct connect. Don't have. Okay? Because you know why? How to say? If Omron to Omron, if let's say I have an Omron drive that can support the configurations, then no problem. So now I'm using Modbus, right? So the HMI I make sure is ready for Modbus command. So I need to do some settings on the HMI. Okay? Okay, go down. No, sorry. Okay. So this P parameter is for the drive setting. Okay? So you can set here. I want to drive. So any drive you want to run, okay, 101, nothing much. Go up, scroll up, 101. Yes, okay. 101 is the drive voltage 230 volt. Because I connected 230 volt here. Okay. Number 2 is the motor hertz. So motor is 50 hertz. Okay. Number 3 go down. Number 3 is the overload current. So overload current they ask you to put based on the drive or the drive rated current times 2. So the current here is 1.28. I just put 3 there. Okay. Then minimum frequency 0. Maximum frequency 50.
This one you have to set yourself.
Yeah, by default it will be 60 by default lah. So if you want to change, I change. Okay, go down. Normally when you buy, it's slowly. Oh, I think this page already. Go down. Okay. Go slowly up. This page slowly up. This one is P1, P6, P6, yes. This is the one. Start, stop means run, on, off. Okay, you see. If I choose now 0 means keep back means I can on off here. Okay. If I use 3 wire means is the stop, start, forward command. Okay. This one using terminal. If 2 wire means it's just forward, backward. Okay. Okay. 2 wire left is a sensor drive will start after stop command. Okay. This one is all using the terminals lah. Okay. Go down. Okay. Number 5 means it's a COM port. Okay. So I'm using number 5. Means COM port means this one. So now the drive will follow what is the command here. Okay, number 7. What is that? What up? Number 7. What? Oh, you have number 7. Then you have number 7, you get 0. Means is not important lah. As I learn at 8. So number 8 is the speed reference. Means the speed will refer to what? If drive potentiometer means here, the speed can increase, decrease. Okay. Internal frequency means I need to set a frequency at, can you see, A409. And this parameter I need to set the frequency. So it just on and off only. So cannot adjust the speed. Already set speed. Okay. Then 0 to 10 means I'm using analog. Reset frequency at these positions or compound.
The A409 is the PLC internal memory.
No. This one now, this is the drive. Drive. It's all from the drive. Okay, go down. Number 9 is the acceleration. Remember, ram down lah. So I put 2 seconds. 2 seconds. 2 seconds. Okay, go down. Okay, this one is for the communication. You go up some more. Oh, that's not okay. The rest of the setting all by default lah. Okay, go up some more. 302. No, go 302. Okay, wait. Now 301. 301. Right. The what is 301 you can check lah. You can check in the this manual. Okay, but I use 302. 302 I use number 3. It's the bow tray. This one later when we set the PLC, follow this. Okay, so wait. So this one we take note.
Bounce rate is actually for
The speed.
The speed.
Yes.
What is the common one that we use a 9006?
What's that?
But just this few days we are using for 9006.
9600, yeah. It's the common one. So, okay, because just now the set point all is for the drive to set what is the maximum speed, minimum speed, all that. This one is for the communication data. This is for the RS.5 settings. Okay, so the baud rate is 9600. Okay, then the node address is like the ID. You know, like Modbus will have for ID. Like Ethernet will have for IP address, right? So Modbus will have for ID. So for this, I set the ID is 100. Okay, go down. This one I just follow the default one lah. For okay, go down. Yeah, okay. The communication format. Okay, the comms format. Okay, I think go down next page. I think I have the comms format. Okay, here at the C306 lah. Okay, I use the because I'm using RTU, right? RTU 8 and 1. Okay, good. These are the settings, the communication settings we need to do. Okay, okay. Then that's all. Go down. Go down page 10. Okay, go slowly up. Okay, wait. Okay, you see, this is the address where we need to send the PLC data to here. Okay, the PLC data. Okay, you see, this is the VFD address. Okay, for this one, you see, wait, first one is forward, okay. Is they call right, okay. The right data means I receive lah, right, okay. Okay, this coding, right, this code we call the Modbus function code. 06, 03, 02, all that, okay. When you have time, you can go to like what's Modbus coding, Modbus addresses. There are so many, okay. Now you see this one, then go down. Can you see the address? Address in decimal, yes. 8192 means, okay, the run command. The command, okay, means the command at 8192. Okay, you see, got how many bits? 16 bits. Okay, so very simple. So when you are doing Modbus, I mean the Omron, the PLC lah, okay. The PLC is simple. You need to tell I want to write a value where to this address. Okay. The one is in the PLC, the program. You need to tell in the PLC program that I want to write a value into this address. Okay, what number? What address? Okay, because this is the command for, so for forward, reverse, stop means, okay, you see how it works is, if I want to read forward, some of the bit must be on. It means, okay, this is, okay, it's not a stop, right? So this bit must be in off. This bit must be on. No jogging. Need to clear the forward command. It means if I see the first bit is 0, second bit is 1, right? Third bit is nothing. The fourth bit, okay, I need to clear the fault if I have a fault, right? Then if I run forward is 1, 0. Okay? If reverse means same thing. 0, 1, 0, 0, 0, 1. Because reverse, right? So 1, 0 lah. Then the stop means is a 0. Sorry, the first one is 1, right?
The first one is 1. Yes.
1, correct. 1, 0, 0. Need to clear the fault. If I have a fault, then the rest is 0. Okay, good. Understand? If this number you convert to decimal is what number? Okay, so it's not a convert, but the data is at the bottom there. So this is 26. This is 42. This is 9. Binary convert to decimal. Okay, good. Okay, go to next.
The code is number 06. So this by default, right?
Yes, default.
The logic command is 8192 is like considered a channel, right?
Yes, 8192 is their channel. Yes.
So right is the
Right means okay, you can write to the channel. Yes.
then the read will be the 03.
Yes, AWC. So you go slowly go up. Okay, you see, writing reference. Okay. So this one is the speed setting. Okay, speed setting is 8193. Okay, and 8193. Yeah. Okay, what is the value is here? It shows that. Can you see? So if you use 500 bits is equal to 500.0 Hz. So it means the range here is 0 to 500, which is equal to 0 to
show that it's started.
Temperature. But that one is a fan automatic. Temperature is automatic. Okay. Until here, okay?
Yeah.
Okay. This is to the right value. Later, from here also you can read value. The read is using function code 3. Okay, good. That is the most important thing. Okay, now and here we already got all the data. Okay. Now the PLC side. Then the read lah. So I want to read here. Okay. At 8448 I can read whether it's already running forward or rotating everything. You go down. Then here, what is this? This one, from here I can get the error codes. You go down. Okay. I just roughly put here. So 8192 is for the command, 8193 is the speed, 8450 is the display my set speed. 8451 will display my current speed. Current speed display. Then this one is the current display, how many amps everything. An example this one is the output voltage display. So all this from this data you can get. Okay. This is from the VFD manual. The data we need from the VFD manual. The most important is this one. The most important is the setting first, parameter settings. Then the parameter setting also, the most important is the command and the frequency. Who going to set? The rest is normal. Like what is the maximum speed, minimum speed, everything. Okay. The most important, who going to command the drive, whether it's the terminals or the hard wiring or the communication. Okay. Same for the speed setting also. Who going to set the speed? Whether the potential meter or the analog or the communication. So these two first important. From this, then you need to get the baud rate, ID, the format, communication format. Okay. If you are using Modbus TCP, the same thing, but here instead of this one, it will be using the IP address. So sure you must have an ID, then no baud rate and format because they are using IP address. Okay, good. Then once done this, we need to know what is the address we want to use. And you say because they already fixed, this is the channel that is for run. This is the channel that is for the speed settings. All that. Okay. Now go down. Oh, okay. This one just now what I said lah, right? And the parameter just now. Okay, the motor, hertz, everything. Okay, go down. So for your reference also you can copy. Okay, this setting. So I just take a picture. Okay, go down.
This is from the PLC setting.
Under the PLC setting, we need to do this. Yes. Okay, I think that's all. Okay, minimize. Now go to the W. This one. Yeah. This is a Omron. Okay. Can I see this one or not? No. Go to
Remember the content is right?
yes, I want to see the content. Okay. No, you click here. Slowly go down. Okay, this one is our programming. Okay, go down. Go down. IO memory, IO allocation. Okay, wait down. IO allocation. Okay, no. PLC setup. Yes. This one is the serial port build. Yeah. Okay, did that. Okay, this is the setup lah. Okay, go down. Go down. Okay, not here. Can go up. Go up again, go to the contact. Go to the contact. See, go all the way up. Okay, go down. Here, scroll down. Okay, this one is the option, the setup lah. Okay, no, you want the setup. Go down. Scroll down here. Okay, next. Pulse output, okay, no, section 12, not using. Go down. Okay, serial communication. Wait. Okay, go to this page. Right, you go here. Go down. RTU 14. Yes. Okay. So here, actually they give some examples also. Here, but they're using the Omron inverters lah. Okay, go down. Okay, can you see how it works? Right, writing the communication, do the communication, the PLC setup, then only the ladder. Okay, go down. Okay, now you see DM fixed allocation words. Okay, this is a normal data register. Okay, understand? Okay, you see, you don't see this first. You see this normal data register.
Yeah.
If I enable the port for Modbus, then only this data register become a Modbus data register. If I not enable, it become a normal data register. Okay. So if I'm using built-in RS232 port for I'm using RS232 lah, right? Now I'm using RS485, right? Okay. These are the settings I need to do. Okay, so what I need to do, very simple. Okay, you see, if I want to command something, it means from here to here, command. Okay, and from here to here, I the response lah. Okay, or I receive. Okay, you see, first one, what I need to do, and D1300 and D1300, I need to tell what is my address, my slave address. So this is the master and this is the slave. Okay, so what is my slave address? Address means the ID. So at D1300, I need to put unusual. But all the number here I put is decimal. But all the number we later want to fix is hexa. Remember, okay? Then at 1301, you need to tell what function code you want to use. So for 0 to 7. But they already tell, okay, if you want to write 6, right? Okay, so 06 or 6 lah, okay? Then now number of bytes you want to use, how many bytes? Okay, so this is one word, right? 8192 is one word. Okay, 8193 is the one word. So byte means 2 bytes, correct? Okay, so at D1300, 1302, I can use 2 bytes. Okay, then what happened? The first one for this D130 at 03, you need to tell what is the address you want to key in data. Okay, so the first one, okay, number of communication data bytes. Yeah, so number of
Data byte is how many?
data bytes means
32.
no, bytes means 8 bits.
Byte.
Yes. Okay.
So 16 bit.
16. Yeah, 16 bit means it's a 2 byte. Okay. Okay. Now. Then. So right now. It means later. So you already tell. Okay. These are settings. You see here. These are the settings. Okay. You are telling. Okay. The ID 100. I want the code is 6. I want to use 2 data from the address 8192. It means whatever you key in at this number, whatever value you put it here, this one will go to this address. That is the concept. So at D1304, let's say you put 26, you want forward. Okay. Then if you put 42, reverse. If you put 9, stop. Okay. Same thing if you want to do for speed settings.
What is 100? D130.
100 is the ID.
Ah.
By ID.
So 02 is the right. 202 is the number communication data type.
This one is how many data I want to send. Okay, good.
The SR 0000 SR is 2 byte. Is it,
Yeah.
is it 2 byte?
Yeah.
Conversion data 128.192 is the command. So D1034 is also communication data. So no need to put
What?
1304.
No need to put. We don't need to put anything. Means, okay. What happen is when you put like this, okay, you're telling, okay, is the ID is 100. This is the VFD. The code is number 6. I want to use 2 data starting from 8192. It means D1304 typically become 8192.
Okay.
So if you key in this value to, if you put in this value to here, it can run. Okay, good. Okay. The same thing for, I want to do for this also, the same thing I need to do.
So the speed set will be referred to another address. Error code.
No. Wait. The same thing, everything is same thing. Okay. So the receive, when you do receive, that is the D1350, D1351. This is 100, same thing. This is become 03. The receive lah, right?
Respond, command and respond.
Yeah, the response. Okay. Then at D1352 you can get the error code. Then at D1353 is the same thing lah. How many bytes? Then the data will do. Okay. Now go down. There's one more thing we need to do. Go down. This is the error code lah. At the 1352 is the error code, right? This is the error code. Okay, go down. Okay, wait. This is the related auxiliary area, the A area. Okay, so what we need to do, if I'm using the 485 port, okay, A641.0.00, okay, I must on. I need to turn on. Okay, then only the master will execute. Okay, I mean the Modbus will start to run. So means you need to manually on this. Okay, but you cannot be continuously on. That's the thing. It must be like on off, on off, on off, on off like that. Okay, can? Then only can do all this. Okay.
What is that for? It's on, off, that's all.
What's that?
It's to on and off, on and off.
Yes, because it must be like send signal, I receive. Send signal, I receive. What's that?
For what purpose?
No, that's how the Modbus works. Because if you only sending signals, cannot. Must receive. So to receive, you need to off first, then send. Off, send. Okay? Okay, minimize this. I made a simple program, just on and off only. I mean, just, yeah, on and off the speed settings. Then tomorrow we can go more. Okay, you close this. Okay, you leave it this one. Okay, go to the setting, go to the serial port. Okay, can you see 960081N? I follow this up. Okay, this setting. Okay, close. Okay, you see what I create is the always on. No, I create a timer 1 second. 1 second, right?
1 second.
After 1 second, this one will on. Okay. Then when this one on, this one start to come. After 1 second, I cut off this. So this one will repeat. So the T0 become like on off, on off, on off, on off. Okay. So what I do, I link to the A641.00. This is the just now the Modbus. Okay. Go down. This one is for the forward and backward. Okay, so I put a 0.2 second pulse. Means it's like continuously on and off, on and off, on and off. Okay. You see, first D100 1300 is what? Note 90. Okay. 100 is in decimal. In hexadecimal is 64.
This one is by BCD.
No, hexadecimal.
Hexadecimal.
Yes, I'm using hexadecimal. They say hexadecimal, right? That way. Okay. Next one, you go. I'm using function code 6. Okay, go down.
Actually, that is quite confusing. Sometimes they using this symbol, I thought it's BCD.
No, that is, it depends where you use. You see, I'm very simple.
Like you said, BCD only have 3 functions.
No, very simple. You see, TIM 0 hashtag 13. TIM X 0 1 hashtag 13. Now which one is BCD, which one is hexadecimal?
Timer, this one is the one, both is a BCD.
Which one?
Both is a BCD.
No.
Oh, okay. X is a binary.
Yes. So hashtag 30 means is a in BCD 30.
BCD.
But here hashtag 30 means is hexadecimal 30, which I can convert to decimal. So that's the difference. If there's no mention, and if the place is not for BCD place, then the hashtag is hexadecimal. If they say that is a BCD, the command is a BCD one, then it's a BCD.
Okay.
Very simple. Simple. Okay. Go down. Okay. I use 4 bytes lah just now. I tried 4 bytes lah. Okay. So 2 bytes also can, 4 bytes also can. Then at 1303, I put the address 8192, which is decimal. I convert to hexa is at 2000. Okay. Now what I do at D10, I put the commands. The command will go to here 1304. What is the command numbers? This is the numbers. Okay. speed settings. Go down, that is for the command, okay? Now the same thing for the speed settings, the same ID, the same write code, the same for data, okay? Now the source, the word I'm using is now 8193, okay? Then I put D20 to set the speed, go into here. Okay, so now you see, now both the speed and the command using the same D1304. Correct? Can you see here? The speed moved to 1304, right? Okay, go up.
This one I can accept, but this one just now you are writing here is decimal.
All these are decimal number.
So
Okay.
you convert it to the
No. What I mean is, you see, you don't get all this. Okay, you see. Set speed D20. I will set the speed, right?
yes.
It will move to the D1304. You go up. You see, the D10 where I put the command also moving to D1304. It's the same thing. So how going to move at one? So that is the reason I put a pulse here. This pulse is the Omron one. You know, the P on. There. So you go up. Here I put normally close. Here I put normally open. So when on, this command will work. When off, the other command will work. Okay? Can? Okay. You monitor. Monitor. No, online, sorry. Yes. Okay, now, and D10 and D20, the others all no need, you just delete.
This one will be
Yeah. All that can delete. Okay, so these two are D10 and this one. Okay, now, and D10 is the command. So you put double click D10. Okay, just put. Why I can't see the value? No, double click at the value. Okay. Go to view. Windows. Watch. Okay, again on. Okay, right. D10. But why I can't see the value here? Why? Wait a minute.
I will download your PLC.
Huh?
I will download your PLC.
No. It's already downloaded the program. It's already inside the PLC.
Oh,
No. I just want to know why the D10 cannot see the value. So no error, nothing. You add one. You delete this two lah. Okay. Now I can see. Okay. You see. 9 the value. It means it's a stop. Okay. Now at the D20 is the set speed, right? Okay, double click. Okay, now you put 500. Yes. Or maybe this one is not monitor mode. Now you forward. No, and D10, yeah, double click. So forward, you need to key in 26. Okay, but tomorrow we go more in deeper lah. Okay, so if you want to stop, you key in 9. Because why I key in 9 or 42, double click. Because here you see, you can key in hexadecimal or decimal also can. That area, you double click again. No, okay, you double click. You see here, can key in decimal or hexadecimal. Both also can. So you key in decimal, automatically convert lah.
2020 is for what? Set was
26
D20.
D20 is to set the speed here. 0 to 500.
Is the frequency here.
The frequency. You put 250. You can see 50 there. Okay, start. Okay, then you start.
Start what? Start where?
Start.
Yeah.
Yes, there you start. 26. You understand what? You see, at 20 you set the speed.
Yeah, 20.
At the 10 you start, stop, reverse. Yes. 25 hertz. So at D20 is you set the speed. So because you put 250 you become 25 lah. Put the 350.
Yes, I put
And then
how do it become 10?
10.
But as you mentioned, you create a function block, right? From pop-ups.
No, if you want to create function block, then you can create the function block.
This is the one you program this one.
I just move forward, backward only. I mean just set the speed, forward, backward. I haven't done any programming yet. I just do just testing just now. So just now I was doing everything. Testing cannot work. After I on and off, then only can work. Because why I do some setting here, I need to on and off.
So you move all these actors.
First from the morning, I just go to manual, I just take down all the notes, everything screenshot. For me also I want to keep the screenshots. Screenshot everything, then only I do the work.
Oh, you're very pro. All the menus is so easy.
Yeah, the thing is need to know where to search in the manual. Then I go to Google also, I Google and check everything for it or not.
So this one all have to convert from the decimal for HSA.
And you do Excel or decimal.
So this one is actually for commands. This one is actually to set.
Same, yes. One is command, one is set speed.
So we are starting at this. This B1303. 303 is the address.
What you can do, you can create a function block, but the thing is this CP1E, can you see no
Every
F3
function block.
Yes, that's the problem.
1303.
If no, you know what? You can download special function block for this Modbus. They already have. You just import their function block. The Omron already have. Just import, just key. You know what you need to key in? The function block will be like this way. The function block will be like this. So they will put okay, what is the node ID? Okay, one of course enable right? Enable node ID. Then what else? This one is the code. Okay, the function code. What code? Okay, how many data byte? Okay, how many data byte you want to use? Then the address. What address? Then the output. So output here will be the fault. If there's a fault, if it is running everything, something like this, they already have a block for you. Just use the block. But here cannot. I don't have, you need to buy the one, like this option board. Then I can put here, because this one can use long-term block, so I can use for this
So means that all these, like for example, this the first one is actually what D1300, 131, 132.
You mean here?
134, yes.
Here?
Yes.
No.
The command.
Here, okay.
It's all this.
Yeah, all
This
this.
is the information. What information is this? All this data you get it from the
Manual.
This.
No.
This
Omron manual. This data I get from the Omron manual.
No, the data here.
This data,
Data is from this.
the right,
Yeah.
what the address, the channel, yes, that manual.
This from this.
PowerFlex manual.
Power flux. Yeah. Power element.
Element. So if you're doing similar thing to another drive, the same things are there. So of course you need to get the part, ID, the format, and you go to the RS485 pages. It's now I screenshot that one is for the RS485 page. From there you will get one is common, one is the same. So they will give you what is the same address that you do here, just key in the same address.
So just you also like for example this one you key as a 2001 is actually 8192.
Yes.
You convert already.
I convert this.
So you do a calculation.
Or I can just put N 8192. So okay.
Can.
Same thing.
So that accept, no?
Yes.
Okay. Then easier.
Yeah, of course. All the value I put hashtag. Like instead of hashtag, I just put the N symbol 100 because this is their style, their format. That's why I use this.
Easy to read.
Because if you put this one, automatically it will convert to hexadecimal also. Because what they try to say is, okay, at D1300, they only accept hexadecimal. It means it's not actually hexadecimal, it is in binary 10101. So I put hexadecimal or I put decimal, the value going to be same. But the symbol is important. At the end, both are binary. Okay, good.
Good.
So now you get the idea.
I get the idea, but I haven't got the idea why you need to put a similar two pulse there.
No, I just put actually any pulse, 1 second pulse also can.
No, I mean why need to have a pulse?
Because both are using the same address. You know why? That is, both are sending command go down.
Yes.
No. To 1304.
Yeah.
Both are sending the same command to 1304.
Yeah.
So I cannot be like always on. If I put always on, which one will go first? The speed will go first or the command will go first? Don't know. So what I do, if I create a pulse, it will always, this one move, something like that. So for my drive, I just need the address only one, the values.
So this is the timer for the configuration of the configuration. So this A64641 is actually referred to
The manual, the Omron manual. In the Omron manual, they say if you are using Modbus, you need to enable this. Yeah, this one. You see, the Modbus command set in the DM fixed allocation mode. Okay. So this is always sent when the Modbus master execution is turned on. So you need to turn on this.
similar design. After the turn on, then it's okay already.
Yeah, it's turn on means it can communicate with me. So that one also I cannot be like always on. But I just now I see some videos. You go up, they do some what programming do for this that. Actually just like one pulse in. Actually I don't need to use this one also.
Delay.
I just put delay lah. Actually I don't need to use this.
Only delay, right? Just direct.
No, need delay, not delay. It's like a second pulse. It's not the delay actually, 1 second pulse, okay? But instead of using this, I can use the P 1 second pulse. Also okay. No problem.
Problem is why you need to create this pulse value.
Because this A641 cannot be continuously on.
841.
one. Cannot be continuously. You need to be on signal. Continuously like on off, on off, on off, on off. That is how the Modbus work.
I want to see this like D1344. This answer here, right?
Yeah, go. Okay, no.
D13.
Here. Under here. So
here mentions D13.
301303 until 1349, right?
Yes.
Okay, because at D1302 you already tell how many bytes.
Yeah.
At D1303 you tell what is the address of the byte.
Yes.
So the following will be the address.
So, but I still also can use a 1305 until 49, right? But now you only 1304.
Yeah,
I can also use 1305, 6, 7.
can, but it depends. So because if I put 8192, it means this one is equal to this. So D1305 is equal to 8193. D1306 is equal to 8194. And this continuous. But this one, because my program is not complete yet. Tomorrow we do some additional program.
Yeah. Okay. Now I got a question. So for example, 1303. Okay, I sure. Okay. You put as a 13034. Since you are just sending the data to this 1304, why not this one I revise to 1305 so that they're not using the same address?
No, that's why I tried. It can't work. Yes. That's why I created two data. Means one I send to here, then one I send to here. Okay, now tomorrow we try to use the 1305.
Okay. Because I just
But according to this, that's how it's supposed to work.
I just wonder because they give this range. So why
not
you using this range?
Yes.
If they can communicate.
Yes.
Oh, interesting. A lot of data I have to check.
Yeah. For the manuals, you get all the data first. Then only you can
Also and I think I want to know that this terminal block.
This is not terminal block, this is the MCB.
Like for example, this one is 3 phase, right? Also the power supply is 415. Alright?
Okay.
This one?
No. What they mentioned here is this one is just two pole.
2 pole plus minus.
No, it's not necessary plus minus because they didn't put LN. If you LN, then it's a live neutral. So it become like an overload switch. This is just an MCB, 2 MCB. So they say it can carry 240 each cable. The one they carry 240 or 415 or 440.
Very one and one up.
This one is like a normal, similar like terminal block. Like a yes, like a switch. So if this one the carry the current is more than 2 amp, then
Both are the same or both is separate one?
separate.
Separate one.
It's not different.
Okay, so and 415 to 4. Like a terminal block.
No, because you see it's linked. This is it must use the same command.
Let me see.
Number 2 and 3, can you see this is small dot.
2 and 4.
2 and 4, there's a dot. So it's linked.
Okay, no choice, I have to understand more.
Yeah.
Okay. Thanks for sharing on this.
Yeah, I just saving.
At least you also know.
No, I just also learn. So I just because the first time I'm doing.
Yeah.
So that's why I at the same time I just screenshot all those data. That's how I do. Anything new I learn, I just print. I just screenshot everything. I save in my manuals. All these because these are not like settings, right? You cannot always remember, correct or not? So I just screenshot it.
Very fast you did.
No, I just using manual. I just go to YouTube. I see how the guys are doing all that. Because the guys are doing so big. Then I see. Then I understand. Okay, why you need to do so many in this one? Just put a pulse there, like the 2 second pulse there can work. So that's why I tried the 2 second pulse.
You can write a comment there. Why you do so much thing?
Yeah. Morning, just play around.
Okay.
You program, play around like just now we discussed, right?
Yeah.
So means we try to like when we can create HMI, I press start forward, stop backward.
HMI.
From the HMI, okay. Then for that maybe we can
VS. The other HMI.
the VSFD and the tellers. We use them. So together we learn the tenders and the PSLT lah. Okay. Then once done, I think before lunch or we can finish. Yeah. After lunch we can continue with Mitsubishi. Yes. Then Mitsubishi to go. Because I think very fast we can go through the Mitsubishi. First day, second day, we can go straight away. We can go to the fintech HMI, the analog. It's the same thing. In Omron, you learn Mitsubishi is easier. And the last day, we can see, we can create a CCD program, but we don't have the device to connect like this one lah, like one thing. So, but we see like how to do the same things here.
That will help me.
Yeah. At least you can understand how it works.
Yeah, otherwise I blur a sort of. What is that the hell? Internet.
Yeah, so many.
Mobiles, coffee bars. I surrendered. But now after I listen to your plan, just forgot the mobile CCD video and what? Yeah, these two. Intercat is the same like
Same like
CCD.
Intercat, CCD, Profit are same thing, but different providers.
Intercat more into which one?
Omron and so far I've seen Omron and back off.
Because I have one project is you see the robot Fana robot.
Fun, okay.
The robot they need to use the Intercat.
Okay.
Intercat to PLC. I don't know what they do because I heard that they use the Intercat because of the I/O port.
Yes, that's what I said. That's what I said. Intercat, I connect, then it can be like an I/O port.
Yeah.
Like a port like this lah, like this only. Then it become like port. So all your I/O just connect here, all the sensors. But the sensors are not normal sensors, smart sensors. It means they carry data, not just on off.
What they say maybe because of the existing robots is not enough the port or whatever or PLC side not enough port. They use the Intercat, then can extend the
I/O.
Is that all?
Can.
Which one?
It's actually similar thing like a CCD.
Is the PLC side not enough port or the robot not enough port? I think so.
I'm not sure because I need to know what they're doing. That's the thing. Actually, got a lot of things need to learn now. So many things. The thing is, need the devices, need money. That's the main thing.
Alright.
Okay, see you.